like everything's loading up. Do a quick sound check. If you can hear me, go ahead and raise your hand on the control panel. And that way I know you can hear me to the audience. Good, looks like some hands are going up as people sign in. So go ahead and raise your hand. Yep, thank you. Good, good, good. Nice to see people from around the world hopping onto this webinar. And looks like it's time to rock and roll. As normal, feel free to ask questions through the chat box or through the question box, and we'll keep an eye on it, monitor it, make sure we can see it. Also, a quick reminder to those that are getting FM credits, FM doesn't always like to approve duplicate programs one year to the next. Just know that this program is different from the normal DIIM, and Lindsay and Carol Ann and Lisette will make sure that you get a different certificate that shows all fire resistance, which makes it different, and hopefully you can get your CEUs, credits, learning units for attending this as well. I'm not sure UL is as concerned as the FM guys are there. Okay, so let's get going. Good morning from the East Coast of the USA. Virginia is the state I'm in currently. Our friend Rich Walke also joins us from the center of US, well, not quite the geographic center, but what we call the Midwest of the USA, close to Lake Michigan in the Chicago area, northwest of Chicago, about 45 miles-ish. And today's program is the FCIA's proper design, installation, inspection, and maintaining protection webinar, not just for fire stopping, but we're going to cover a worldwide view of many of the standards of not just fire stopping, but some of the other opening protectives that protect breaches in fire resistance rated assemblies. So here we are, January 29th, 2025. Hard to believe the new year is a month in, but here we go. So my name is Bill McHugh, Technical Director for the Firestop Contractors International Association. Rich Walke, Technical Director at the CTI, Creative Technologies Inc., also joins us. And together, we're going to back and forth throughout this 2-hour program to make sure that we cover a lot of good stuff. So 2 hours worth of continuing education. If you can't hang with us for those 2 hours, feel free to drop off whenever you need to. Your certificate will reflect how many hours you stayed on the webinar. So let's get started, and welcome to the FCIA's webinar. First thing I always ask for a conference or a meeting is, where's the fire exits? I'm running out the door if the smoke alarm goes off, and then Rich will take over because his smoke alarm 865 miles away might not be going off. But regardless, always know where your fire exits are, 2 of them, and keep an eye on whether they're blocked or not. A big thanks to the FCIA members, certainly the National Fireproofing Contractors Association too, because many of their members are on this as well. And we've been joining together with them to do symposiums in Canada, in the Middle East, and other places as well. I've had some great success with both organizations. So a big thank you to the FCIA contractor members that have already renewed their dues for 2025. If you haven't yet, please do. Firestop distributors, reps, and friends, manufacturers, and consultants, we're glad to have you on the webinar as well. If you're not a member, we urge that you join the FCIA. Just go to fcia.org, sign on, click the Join Now button, and become a member of the FCIA. Because your dues pay for what we do. Without you, it's hard for us to represent the industry where it needs to be represented. International Code Council, ASTM, NFPA, Construction Specifications Institute, Construction Specifications Canada, Departments of Civil Defense throughout the Middle East and India and other parts of the world. Not just me, but also our friend Abhishek Chabra, who resides in Dubai and has been spreading the good word of the DIIM of fire stopping and effective compartmentation, structural fire resistance in other parts of the world. In fact, we just signed a memorandum of understanding with our friends in Australia and then also in Mexico and Brazil. In Australia, thank Abhi for that work. He also did a program with the Society of Fire Protection Engineers trying to raise the awareness of fire resistance and fire stopping worldwide. The FCIA has been quite busy in its 25-year history, celebrated in November of 2024. But actually, think about it, the association formed in June of 1998. We don't celebrate that date. We celebrate the first conference, January of 1999. Rich was good enough to, at the time he was working for UL, get us the corporate conference room for 40 of our best friends in the fire stopping industry, and off we went with our association. During that program, 26 years ago, 27 now actually, 27? Yeah, 27 years ago, no, 26 years ago in January, what did we do? We talked about how do we separate the contractors that understand fire stopping, the listings, the manufacturer's instructions. How do we separate those contractors from those that just think we're flinging red goop at a wall and just making it look pretty? How do we find a way to do that? That's where the UL Qualified Contractor Program, the FM 4991 contractor programs came from. There are management system-based programs that separate the contractors that know what they're doing from those that don't. What about special inspection? How do we get inspection in the codes? We asked the question. It took us till 2000 when we asked ICC's Mike Pfeiffer, how do we get the inspection in the code? And he said, hey, Bill and FCIA, do you have a standard and have you put it in the building code? Because it's your code, your standards. Well, that's where your standards committee was formed, and off we went to work with Bill Koffel, our code consultant, and others, the manufacturers at ASTM, to be able to put these standards, ASTM E21742393, in the building code. And we said, okay, how do we qualify the companies that are doing inspection, IS AC291? More questions were asked. Hey, I'd like to train our staff. How do we grow the training program? That's what the FCIA Fire Stop Education Program does. Contractors, inspection agencies, and others. And what about resources for everyone else? That's at FCIA.org. Think about those resources. The Life Safety Digest, 2005's FCIA Board of Directors said, we should have a magazine, well, not just Fire Stop, but let's make it for all fire resistance. That's when the FCIA's Life Safety Digest was born. And 20 years of this magazine is archived at FCIA.org. It's a resource, a huge resource with great technical articles that can be referred to year in and year out. For the advertisers, your ad lives on in perpetuity at FCIA.org. Those people that advertised in 2005, their ad is still in that magazine. So although you're paying once, you get 25 years worth of exposure. The FCIA's Fire Stop Manual of Practice is on its 8th edition. In the next year, probably 2026, you'll see the 9th edition come out, and we'll be updating a whole bunch of stuff over the next couple of years. That Fire Stop education program, relatively new, it's only a few years old. It's moving and shaking. Level 1, Level 2, Level 3 are all available for you to have. The Spanish version's coming soon. International version coming soon. A Level 0 for the basics of for a new employee coming soon too. A lot under development that's going to take place. But right now you can train your employees as a company, an FCIA member company. $1,000 gets you unlimited access plus a portal where management can look at where employees are in their progress through Level 1, Level 2, and Level 3. FCIA's education for the FM and UL Fire Stop exams. We just did one early last week that educated many of our friends in the Middle East and elsewhere. The code development process at NFPA, International Code Council, the National Building Code of Canada, is ongoing. Every 3 to 5 years, 5 years in Canada, 3 years in the international codes, we're doing something to make sure that the codes reflect what is actually happening in the field. Same thing with the standards development. At ASTM, we're there every 6 months, working on the ASTM E2174, 2393 standards, and much, much more. So let's talk a little bit about fire stopping and fire resistance. I love this slide because it really tells a story. It tells a story that says all fire resistance, all fire protection items work together to provide a safe building. How do we prove that? Real estate research says there's about 11,000 buildings 20 stories and higher in North America. 70% of those reside in basically 6 areas: New York City, San Francisco, Los Angeles, Honolulu, Chicago, and Toronto. Lots of tall buildings 20 stories and higher in those cities. Most of them in the North America, 70% of them. I didn't do Mexico City, but you know, there's quite a few in there as well. And if we put that in, it probably jumps the number even higher. What's common with all those buildings? And I'll say this about Mexico City too. Fire resistance and fire resistance rated compartmentation were the primary means of protection in the buildings, with sprinklers and alarm systems added later. Other parts of the world use fire resistance first. You know, sprinklers aren't mandated in other parts of the world as they are in North America and in the US and Canada. So therefore, fire resistance is primary and very, very important. Buildings are safe because that fire resistance is there, and the sprinkler is added, and the alarm system to notify the occupants to get out of the building quickly. It's all of these things that work together to produce a statistic that says buildings are safe. The sprinkler industry gets to the code hearings and says 99.9% of the time sprinklers are working, so therefore these buildings are all safe. Well, I agree, but it's not just the sprinkler that made it safe, it's everything. So today's program we're going to hit is the proper design, installation, inspection, and maintaining protection of fire resistance in buildings. And we're not just going to cover fire stopping, we're going to cover fire stopping and other fire resistance items. And we're going to try to contrast some of the IIM in those assemblies, in the breach protectives, the wall itself, the horizontal assembly, just to give you an idea where the fire stopping and fireproofing industry is that's different than what you would find in other industries as well. I mentioned the fire stopping for contracting, the FM and UL contractor programs, plus manufacturers education, plus the Fire Stop education program means an educated workforce. It means a quality contractor getting the installation right. Our industry has done the ASTM E2174-2393 standards, and a PA 80 exists for other opening protectives on the inspection and maintaining protection. Some industries have done more in each one of these pieces of the DIIM. And you'll see that as we go through it as well. So right now I'm going to take the slides, toss them over to Rich so that he can drive the bus for the next several slides. We'll go back and forth as we go through this nice 2-hour program. It's great to have the extra time to cover the things we like to cover. So Rich, the floor is yours. We'll let you have at it.
Okay, great. Thank you, Bill. And good morning, good afternoon, good evening to everyone in the audience. Thanks for joining us. We've got an extended program here today. So we've got 2 hours to cover the topics, which should give us plenty of time. And as Bill has already hinted, we're going to look at a much bigger picture today than what we typically have the opportunity to do in a 1-hour program. Bill's already introduced the DIIM concept. So we're going to look at all 4 sides of that. We're going to look at the D, the design end of it, code, standards, specifications. We're going to look at the installation requirements, the inspection requirements, and then ultimately conclude with the maintenance requirements. So I guess before I go on, Bill, just let you know that your slides were not advancing as you were doing your first part of the module. But
well, that's my goof. I didn't press the go button, so that's the way life goes sometimes. Sorry.
Okay, no problem. So, I'm going to start by talking about the codes, and I always talk about the concept of codes, standards, and listings all going together, fitting together. The codes being the highest level document that sets the I guess the intended level of safety that's asked for. And then we have the standards, which are subservient to the codes, which gives details on what actual testing is needed and what the requirements of those tests are. Sometimes it's a product standard, which gives the requirements of the product in the standard. Sometimes it's a test method where the requirements are truly in the code. And then we have some cases installation standards. Classic example of that would be NFPA 80 for fire doors or opening protectives. So anyway, so starting with the codes then, here in the US, we use the concept of model codes. Model codes are published by some private non-governmental entity, such as the National Fire Protection Association, the International Code Council, or the International Association of Plumbing and Mechanical Officials. And those organizations publish these model codes developed through a consensus process. Bill and I have talked about that many times. We are both heavily involved in that, have been for a lot of years, but that's what or how those model codes get developed. Ultimately, they get published by their respective organizations. And in our area that we're involved with, fire protection, typically the codes come from either NFPA or ICC, the International Code Council. And then from there, they are adopted by individual local municipalities or county agencies or state agencies. We'll get to that part in just a minute. But talking about the model codes for a minute, again, the two primary organizations we get involved with are NFPA and ICC. NFPA publishes two documents that are of interest to us. The NFPA 101 Life Safety Code is somewhat of a combination of a new construction code and a maintenance code. So it includes information covering both of those topics. It is widely adopted by a number of organizations, primarily the healthcare industry. Any organization here in the US receiving money from the government, the US government for what's referred to as Medicare, has to comply with the NFPA 101 requirements. 101 is adopted also on a local basis by other state or local agencies. Classic example, that state of Florida, the fire officials require compliance with NFPA 101. And so that's widely adopted document. There's another somewhat similar document, NFPA 5000, which is a true building code. Unfortunately, it has not received any sort of widespread adoption or acceptance here in the US. Back in the early days, just after 2000, there were 2 municipalities here in the US that had adopted that. Not sure exactly how many currently have adopted it, but it's very infrequent that jurisdiction has adopted NFPA 5000. In most cases, most local agencies, be that the individual municipality, county, or state agency, have adopted the codes from the International Code Council. The building code on the ICC side, of course, is the International Building Code, covers new and existing buildings. They also have another code that's not on the slide, but we'll talk about it a little bit later, called the International Existing Building Code. It's used primarily for cases where you're renovating, adding on to or altering an existing building. And because of that nature of the code, it's got some important information on it, which we'll be talking about a little bit later, that talks about archaic constructions. So there's a resource A within the International Existing Building Code that describes a particular type of construction and then concludes what its fire resistance rating might be or would be. So it's great if you're faced with that situation, you're involved in remodeling an existing building, you don't know what the rating of that existing construction is, so you can backtrack and determine it through the International Existing Building Code. So from that perspective, it's a very useful document for our industry. And of course, ICC also publishes their International Fire Code. It governs how the building is used once it's occupied, both in terms of what you can do in that building, what you can put in the building. But from our perspective, what's important is it covers the maintenance requirements for fire resistance rated construction or passive fire protection, in addition to the maintenance of other fire protection features, sprinklers, alarms, and those sort of things. So it is a very important document for our industry. Now, when I talked about the adoption of those model codes by local agencies, and the example we've got in this slide shows that the city of Chicago, I guess I'll say where I'm located, I'm in suburban Chicago, but the city itself, city proper, has adopted the International Building Code 2018 edition with amendments. And that's kind of the key, is when some organization adopts the model code, typically they'll include some amendments, some changes that they feel is important based on their experiences. Sometimes those experiences are bad experiences, fires. We had a fire, this, that, or whatever happened. So we want to prevent that from happening again. So they make changes to the model code to address that particular issue that they're concerned with. City of Chicago, City of New York, Los Angeles, those bigger jurisdiction, when they adopt the model code, they make significant changes. So that was the case with the City of Chicago. They made significant changes. Now the little local jurisdictions, my little sleepy suburb of Chicago, they make very few changes because they don't have the experience, they don't have the expertise to start altering those model codes. But nevertheless, regardless of whether they make amendments or not, those model codes are adopted by a legislative type action by that jurisdiction, and then they become law. So anyway, that's how we work it here in the U.S. In Canada, it's a little bit different, of course, but and not just Canada, but other parts of the world, we have other codes. Canada uses their National Building Code of Canada. I'll say that code, although editorially is significantly different, the base requirements are very similar in Canada as here in the U.S. And to use an overused phrase, fire burns the same way in Canada as it does in the US, so the basic requirements are similar. United Arab Emirates has their fire and life safety code, and that's both a combination of a building code and also a fire code. National Building Code of Canada, the code used, I'm sorry, of India rather, is the code used in India, and more generally then, you know, pretty much all developed nations around the world have some variation of a building code in place. Some cases, those codes are developed by that country individually. In some cases, they'll follow the codes from some other parts of the world, for example, from the US or from the European nation. So anyway, but it's ultimately up to that country to develop their own codes. And I guess one thing I missed earlier, we talked about the National Building Code of Canada. They have a similar code. They have a National Fire Code of Canada, which covers the same sort of information that the International Fire Code covers here in the US. Talks about how you use the building, what's permitted in that building, and maintenance requirements and things like that. So that's very much an integral part of the Canadian requirements. So let's talk about fire resistance now. And we're going to start basically with fire resistance. Then we're going to move on to the various breaches or openings in those fire resistive rated assemblies. So fire resistance by definition is a property of the materials or assemblies that prevents or retards the passage of excessive heat, hot gases, and flames under conditions of use. And there's some standards shown here. ASTM E119 or UL263 is what we use here in the US. Canada, they use ULC S101. Good news is those three standards are, from a technical perspective, for all practical purposes, the same. Many years ago, approximately 20 years ago, UL recognized that a test run here in the US in accordance with ASTM E119 or UL263 can also be used to show compliance with the Canadian requirements in S101. So that's the good news for manufacturers that are marketing products in both countries. So here in the US then, when we're looking at the International Building Code, Chapter 7 is what I call the nuts and bolts of fire resistance. Once you know what rating is required through some of the earlier chapters of the codes, 3, 4, 5, and 6, now we go to Chapter 7 to determine how we show compliance with those requirements. And 703.2 says fire resistance shall be determined in accordance with section 703.2.1 or 2.2 without the use of automatic sprinklers or other fire suppression systems being incorporated. So, that's been a very contentious topic for the last 13, 14 years here in the US about whether you can establish a fire resistance rating through the application of water to the assembly during the fire test. And we finally got that resolved with the 2021 version of the code. So this is the language from the 21 and 24 version of the IBC. So the base requirement is you determine fire resistance without the use of sprinklers. 703.2.1 talks about tested assemblies. Fire resistance shall be determined in accordance with ASTM E119 or UL 263. So I'm going to stop right there and say that everything that's done for fire resistance really is based on those standards. When we get to the next section, the analytical methods, we'll see the starting point is always those two test standards. You need data by those two standards in order to develop any sort of streamlined method of showing compliance. So those are the root requirements for all fire resistance here in the U.S. And then the code goes on to talk about some of the details on how those tests are conducted. For example, non-symmetrical walls shall be tested from both faces. So if you have a non-symmetrical wall, what's a classic example of a non-symmetrical wall? Two cases, maybe an exterior wall or a shaft wall. In those cases, the wall is tested twice. One test from side A, the other test from side B. The rating established is the lesser of the ratings between those two sides, or sometimes the listing agencies will break it out. Tested from the exterior side, it's rated at 1 hour. From the interior side, maybe 2 hours. So any case, beyond that, then I guess moving on, I don't have a slide to support it, but the second method of determining fire resistance is through analytical methods. Those are your practical methods. Go to the UL directory, go to the prescriptive or calculated fire resistance in the codes, and that's how you can then show compliance with the code requirements. But again, those methods are still based on those two test standards. And then the third method is through the alternate materials and methods section 104.2.3 by the latest 2024 code, allows some alternate methods of looking at fire resistance, including the use of a fire suppression system during the conduct of the fire test. So moving on then to further on in chapter 7, one of the basic principles of fire resistance is you always support fire resistance rated construction on construction that has an equal or greater rating. And there's a couple exceptions in the code to that, but for the most part, you're always supporting rated construction using rated construction. Continuity provisions are another classic example of provisions that are in the code. So it's in this case, we're talking about fire barriers shall extend from the top of the foundation or floor ceiling assembly below to the underside of the floor or roof sheathing slab or deck above, and should be securely attached thereto. So bottom line is these fire barriers go from floor to the bottom of the deck above to complete the continuity of that barrier to prevent fire from breaching, for example, above the top of the fire barrier. And so each type of assembly has similar sort of continuity provisions. And as far as the standards that are used to establish fire resistance here in the US and in the United Arab Emirates, we use ASTM E119 or UL 263. Now, there was a third standard for fire resistance, NFPA 251, that was withdrawn somewhere around 2005. And kind of the realities of it is the three standards writing organizations in the US as it pertains to fire, UL, ASTM, and NFPA got together many years ago and said, why are we duplicating efforts? Why are we writing three standards, one from each organization, to cover the same test procedure? It's a waste of resources. Standards development is a very resource intensive process. So we're spending a lot of extra time for nothing. So ultimately it was agreed that as time moved forward, one of those three organizations would withdraw standards where there's duplication, and following through with that philosophy, NFPA did withdraw 251 back around 2005. In Canada, we use ULC S101 to develop fire resistance. As I said before, for all practical purposes, that's the same as the two US-based standards. And then in Europe and India and the UK, they use other standards. ISO 834 is the international standard. In the UK, they use BS 476 or EN, which is European standard 1363. So conceptually, I'll say there are similar to the North American or US-based codes, but there are some significant differences. So it's certainly not appropriate to say they're identical. But moving on, then I like this first line of this slide. Products become systems based on test standards or based on testing to test standards. So, you take some product, whatever it is, call this a piece of gypsum board. What's the rating of this gypsum board? It has no rating. It doesn't have a rating until it's installed in some specific manner to create the wall assembly or floor ceiling assembly or column protection system. Then it becomes a tested listed system that has a rating. So once again, our US-based standards, ASTM E119, UL 263, are the standards that are used to develop those systems. And in the fire stopping world, we have a laundry list of standards: UL 1479, ASTM E814, FM 4990. On the joint system side, we have UL 2079 or ASTM E1966, ASTM E2307 for perimeter fire containment, 2837 for continuity head of wall joint systems, and then 3037 for movement of penetrations. In the door arena, referred to here in the US as opening protectives, we have three primary standards. We have UL 10B, UL 10C, and NFPA 252. There are a couple more standards we'll talk about in a minute, but those are the true fire test standards. For rated glazing, we use UL 9 or NFPA 257 to establish what's referred to as a fire protection rating of that glazing. Or we have UL 263 or ASTM E119 that develops a fire resistance rating of glazing. And it's kind of interesting. We think of glazing, of course, as something that probably is not going to withstand a fire, and that certainly couldn't be further from the truth. There are fire protection rated glazing and fire resistance rated glazing. Fire resistance rated glazing meets the exact same requirements as the gypsum board wall, for example, or a concrete block wall. So it truly is a very remarkable product that has the ability to provide a fire resistance rating. Slightly lesser ratings referred to as a fire protection rating developed by UL 9 or NFPA 257. That type of glazing prevents passage of fire through the glass. It withstands the heat without breaking out. It meets a hose stream structural integrity test, but it does not limit the amount of heat passing through that glazing. So there's a significant amount of radiant heat being given off by the unexposed side of that glazing during a fire exposure condition. So it's a slightly lesser rating than a true fire resistance rating. And then on the damper side of things, we have three primary standards: UL 555 for fire dampers, 555S for smoke dampers, and 555C for ceiling radiation dampers. So ultimately, after running tests to all of these standards, developing a published listing of these standards, that listing or system becomes the suitability statement. It describes how the material was tested and how it performed when tested in that manner. So in terms of the testing for fire resistance, the standard divides the building into individual components, columns, beams, floor ceiling or roof ceiling assemblies, and wall assemblies. And those letters that you see beneath each type are really just the UL design designations, how UL publishes those listings. Columns are published under the X, Y, and Z series designs, et cetera, et cetera. So that's specific to UL. And all fire resistance tests, whether it's the basic walls, floors, ceilings, etc., or fire stop system, joint system, door, or damper, are tested to a standard time temperature curve. Now, the orange curve on this graph represents the curve that we use here in the US. That curve suggests we reach a temperature of 1,000 degrees Fahrenheit in 5 minutes, 1,700 degrees Fahrenheit at a 1-hour time period, and 2,000 degrees Fahrenheit in a 4-hour time period. The blue curve is what's used in other parts of the world. For example, the European community, the British or UK standards, and the ISO standards. You see, it's a little bit different. And don't draw any conclusions on the relative severity of these two standards, two curves, because there's another very significant factor influencing that is how those temperatures are measured. So I won't get too involved, but the method of measuring the temperature within the furnace is different by the US-based standards versus the European standards. So don't look at that and automatically conclude the European standards are more severe. That may or may not be the case. So let's look at the testing of these basic building elements. And we're going to start with a column. By far the simplest. The sample size is a minimum of 3 meters or 9 foot in length. And in most cases, well, I'll say in all cases here in the US, those assemblies are tested non-loaded or unloaded. Other parts of the world do test the columns with a load applied during the fire test, but we don't do that here in America. We test them unloaded and they use a temperature criteria. So this photo shows a column that's been protected with an intumescent fire-resistant material. It's inside of UL's column furnace. These long rods projecting through the walls of the furnace are thermocouples, which are used to measure the temperature within the furnace so many inches away from the column. And these round ports in the back and on the side walls and ultimately on the front wall, once we slide that door closed, are the gas jets, the ports that supply the natural gas. So in the case of a column test, UL purchases a column, and I shouldn't say just UL, the testing laboratory will typically purchase the column, pour concrete cap on the top, concrete cap on the bottom, put some legs on it to keep it upright, and install thermocouples embedded into the steel so that we can measure the temperature rise during the fire test. So in this case for column, the criteria really relates to temperature rise. So the fourth door of this furnace is slid closed, the natural gas jets are ignited, and then the temperature within that furnace follows a standard time temperature curve. And when the temperatures of the steel reaches 1,000 degrees average or 1,200 degrees at any individual point, that's referred to as the temperature endpoint or fire resistance rating of that particular column protected in that particular manner. And I do have a note here that says support load if tested load bearing. Again, that's typically not done here in the US. It is done in other parts of the world. But bottom line is, looking at the right-hand side, this is why we run fire tests. The column shows significant delamination of the fire protection material that occurred during or immediately after the test, or in particular during the test. And we can do fire modeling on straight fire resistant materials quite easily, but what those fire models can't account for is the fall off of material. They can't predict that. So that's why I always say, and UL's policy was always that we use fire modeling to supplement fire testing. Once we've established the fact that material stays in place, then we can use fire modeling to monitor heat transmission through the assembly. So now let's look at how we test beam assembly. So what you're looking at on the right-hand side is a photo of the UL test frame. It's nominally 14 foot by 17 foot, the heavy steel and concrete frame. The sample is built within that test frame. So we've got 4 individual beams installed in one test assembly. That's very typical. Those beam lengths are minimum of 4 feet or 12, minimum of 4 meters rather, or 12 feet. In general, what's referred to as a full-scale assembly. And the concept of full-scale assembly is that it's large enough to allow the assembly to be loaded during the fire test, and it's large enough to get a significant amount of deflection. So mid-span, we may get somewhere in the neighborhood of 10 to 12 inches of deflection on that beam at the mid-span. And what that does is, as it's deflecting downward, it's placing the protection materials into tension, and I guess I'll say causing or promoting delamination of the material. So if the material is prone to delaminate, it's going to do so under those conditions. And that's why the standard is very specific in terms of the minimum length and the fact they're loaded during the fire test. So moving on then. So here we've got that assembly we saw earlier has now been finished. The steel beams were in place early in the earlier photograph. Steel deck is then put on top of the steel beams, and then shrinkage control mesh is put in place. And then concrete's poured. So you can just barely see a break point, control joint, whatever you want to call it, between these 4 adjacent sections. So we've got 4 independent sections that can be tested for different rating periods during this one fire test, and ultimately they're allowed to deflect differentially compared to the neighboring slab. And so after the concrete's cured, then the manufacturer's rep comes in and installs the protection material. In this case, it's a sprayed fire-resistant material on the underside of the assembly, in this case, to the beams itself. This assembly is representing a construction method where the steel deck is not protected. In some cases, a steel deck may be protected. On the lower right is a photograph kind of contrasting how things are tested in the lab versus what they look like in the field. So if you compare the photos, what's being done in the lab directly compares to how these products and systems are being installed in the field. So we've got a direct tie-in between field applications and testing in the laboratory. So this is the furnace that's used for determining the fire resistance of those beams, and for that matter, floor ceiling assemblies. Andy is standing in the furnace, so you get an idea of the relative size of the assembly, 14 foot by 17 foot. So it's a full scale, it's a large scale assembly. The pipes coming off the bottom of the furnace are the natural gas jets. These taller pipes are the thermocouples used to measure the temperature within the furnace during that test. Follows that standard time temperature curve. So the assembly is placed on top of the furnace then, and this rigging, steel rigging on top of the assembly is what's used to apply the load to the assembly during the fire test. So you'll see, or just barely will be able to see, the hydraulic rams that are applying the load to the midpoint and quarter points of that beam assembly. So the furnace fire is ignited. The furnace temperature follows the standard time temperature curve. Loading is being applied simultaneously. As the beams heat up, they lose their strength, they begin to deflect, and ultimately the conditions of acceptance would be that the assembly needs to support the load, or there's some temperature limitations. And temperature limitations would be 1100 degrees Fahrenheit as an average of thermocouples on any beam, or 1300 degrees Fahrenheit at any individual point. And one might ask, why do we have both supporting the load and temperature as a criteria? It kind of relates to the restrained versus unrestrained argument. I won't get involved in that right now, but that's why measurements are made both ways. As far as a floor ceiling assembly, it's pretty much the same. We have a large scale sample, minimum 180 square foot. Again, no dimension less than 12 foot. Once again, they're tested full scale with a load designed, a load applied to the assembly during the fire test. So the construction process is very much like what we just saw for the beams. So I won't show that to you again. This is a photo of a assembly placed on top of the furnace. You might ask, what are these tanks on top of the assembly? Well, that's how the general floor area is loaded. They're loaded with water tanks. So the beauty of water tanks is you can fill those tanks to whatever depth of water is necessary to load the assembly to its maximum design capacity. And like we saw for the beam test, beams are loaded to their maximum capacity through hydraulic rams, again, applied through this steel loading equipment placed on top of the furnace. So this is a photo, once again, of an assembly after the fire exposure test. And once again, we see pretty significant delamination of the protection materials. And so again, this is why we use fire testing and not fire modeling to determine fire resistance ratings. The one unique thing about this one is you don't see much deflection. And I said before, we might get 10 to 12 inches of deflection. We don't see that here. Why not? Because the material delaminated very early in the test, before the steel beam reached any significant temperature, so we didn't get to that point of deflection. Manufacturer chose not to continue the test because the material had delaminated, so that's why we didn't get the deflection. So we have 4 criteria for those floor ceiling and roof ceiling assemblies. The assembly needs to support the load, prevent flame passage, meet certain temperature limitations on the top side of the assembly, and also the beam temperatures we saw earlier would also apply for a floor ceiling assembly. That 1,000 degrees Fahrenheit, I'm sorry, not 1,000, 1,100 degrees Fahrenheit average, 1,300 degrees Fahrenheit individual point. So at this point, I'm going to let Bill cover these next 2 slides. I'll maintain control of the PowerPoint, but so go ahead, Bill.
Sounds like a good plan there, Rich. Let's talk about a couple of things. I mentioned early on that we were going to talk about the DIIM for several of those things. Rich just went through a lot of structural fire resistance, fire testing, and know that ties in with fire stopping, and that fire stopping is installed in a fire resistance rated wall assembly. The wall assembly, according to the International Building Code and other codes around the world, says that fire resistance rated assembly needs to rest on a fire resistance rated assembly of equal value. How do we do that? That's the structural fire test that Rich just went through, the ASTM U119 UL263. In order to protect steel from reaching its temperature at which it softens, 1,000 degrees-ish Fahrenheit, 1,300 degrees-ish Fahrenheit, fireproofing is applied to it, whether it's intumescent fire-resistant materials, spray fire-resistant materials, or boards and wraps. Those materials need to be applied in a way that reflects what the listing is, in other words, the thickness of fireproofing in the listing, and then also the manufacturer's installation instructions. So in the manufacturer's instructions is the temperature of which the steel has to be to receive the material, application of the fireproofing temperature limitations, and much, much more. The manufacturer knows their chemistry, they know how it should be applied, and that's where the manufacturer's instructions come in. Those are so important that those 2 things are in the building code. Install in accordance with the listing and the manufacturer's instruction. The listing would be derived from the UL Product IQ. So the NFCA, the National Fireproofing Contractors Association, built 2 programs for this installation to help with its quality and make sure it's done right the first time. The NFCA has a contractor accreditation program that's basically an education and exam. The NFCA does the education, and an exam takes place where a person takes an exam, good industry exam, fair one. We have a good sized percentage of people that don't pass it. It tells us it's credible. And once they pass that exam, either on spray fire resistant materials or intumescent fire resistant materials at 80% or better, they become a DRI, a designated responsible individual, when appointed by the company as that DRI. Those people keep CEUs 30 every 3 years, and the continuing education credits are attending webinars like this, conferences, et cetera, et cetera. The contractor company gets a logo on the bottom right-hand side. Sometimes it's one or the other or both. And annually, they pay a fee to be a accredited contractor. You don't have to be a member, and no audits are required for this. The second one, to switch the slide to the next one, is the UL Qualified Fireproofing Contractor Program. The NFCA worked with UL at the same time that the FCIA was working on their Qualified Fire Stop Contractor Program. They're paralleling, so this is time frame 2003 to 2007. At the time, Hugh Dudley was the executive director of the NFCA, and I was working on the UL Qualified Contractor Program with the FCIA member volunteers from the accreditation committee. The Qualified Spray Fire Resistant Material Contractor Program is similar to the FCIA program in that it's got a DRI part of it too. The difference is that the UL people look at the NFCA's exam as the exam to pass. That's a difference between the two, in that the FCIA, the Fire Stop Contractors Program, the FCIA provides the education and the education manual, the FCIA Fire Stop Manual Practice. and they pass a UL exam for that particular program. In this one, again, it's the NFCA's exam that gets you there, and then the contractor has to build a management system with 10 points met. You know, how do you manage the things you do as a fireproofing contractor to get it installed in accordance with the listing and the manufacturer's instructions? In a nutshell, that's what these contractors do. There's a groundswell, I'll say, of companies about to get accredited. There's only a couple currently for the fireproofing. There's a couple hundred, over 100 UL qualified contractors in the UL qualified Firestop contractor program. But there's an audit, an initial audit, and then an annual audit by UL personnel, third-party qualification program. Pretty cool program. And it's something that the fireproofing industry has done to have the eye of installation there. The eye of inspection, they've had special inspection since the legacy codes back into probably the 40s, 50s, 60s, 70s for fireproofing. And the M, Rich will talk about that later on, because fireproofing is included in the maintaining protection of the International Fire Code. So back to you, Rich.
Okay, thank you, Bill. Yeah, and just to make one more comment based on what Bill said about special inspection of fireproofing. I got involved in that industry in 1987, and special inspections were already a well-established concept for fireproofing industry back in those days. When exactly it came about, I don't know, but it was certainly well before then. So anyway, let's continue our discussion on testing. Now we're going to look at wall assemblies. Before we do that, let's look at the codes. Codes define a number of different types of wall assemblies, each having a specific use by that code. And the definitions of these types of walls do vary between the various codes, regardless of whether, or depending on whether it's an NFPA code, an ICC code, Canadian code, Indian code, United Arab Emirates code, etc. So here's a kind of a grouping of terminology. The blue terms are what's used here in the US: exterior walls, horizontal assemblies, firewalls, fire barriers, fire partitions, smoke barriers, and smoke partitions. All unique and all have very specific requirements beyond just a fire rating associated with them. The red terms are what's used in other parts of the world, the UK and India. The green is what's used, terminology used in Canada. Canada also uses the phrase firewall. So they have two terms, firewalls and fire separations. But in any case, just different terminology describing the types of walls. There's a last bullet point right at the bottom, archaic assemblies. Those aren't really defined assembly types, but more just a reference to assemblies using materials and construction techniques, which are realistically no longer being marketed, no longer being used. But if you're in that renovation business, then you will run across these assemblies, and you will need to try to backtrack to determine what their ratings are, either through the International Existing Building Code or through other industry documents. So, this slide basically talks about systems and materials. And one thing we've touched upon a couple times is, what is the point of fire resistance? And let me make it crystal clear then. Fire resistance really has two intended functions: the structural functions, referred to as a structural fire resistance, or compartmentation, the compartmentation side of fire resistance, where you want to contain the fire to the room or floor of origin through materials that resist that long-term impact of fire. So we do that through protecting the structural steel, protecting the or building the wall assemblies of materials that withstand that fire exposure. So once again, we're talking wall assemblies. We use the same standard time temperature curve for walls as we do for the horizontal assemblies or structural elements. Here's a photo of a fire test on a gypsum board wall assembly being conducted at the facilities of our friends at USG. They have a testing laboratory not far from where I live, just north of me, Libertyville, Illinois, where they actually run ASME 119 or UL 263 fire exposure tests, primarily on their wallboard products. And I shouldn't even limit it to wallboard, but to their products that are used in the construction industry. And for wall assemblies, they're tested to ASTM E119 or UL 263 or ULCS 111. That's 101. And the criteria really relates to flame passage. There can be no passage of flame through the assembly sufficient to ignite cotton waste applied to the unexposed side of the assembly. They need to limit the heat transmission to the unexposed side to average temperature rise of 250 degrees Fahrenheit above the ambient temperature, or an individual temperature rise of 325 above the ambient temperature. And then they need to pass a hose stream test, a structural integrity test, which is what you're seeing administered in the photo to the right. That hose stream test is, water stream is directed through the assembly using very slow horizontal vertical motions, impacting all sections of that test assembly, and ultimately the condition of acceptance suggests there be no through projection of water through that assembly during the hose stream test. The international standards are similar, temperature limitations are similar, the flame passage is similar, but typically they do not include the hose stream test. That's a North America specific test that's conducted. They use different terminology though to describe their results. They describe an integrity rating, which relates to passage of flame through the assembly, and then they define an insulation rating, which adds that heat transmission parameter. Here in the US, we just call it a fire resistance rating. It has to meet all of the parameters. Europe and other parts of the world, they differentiate that. And typically we have no contractor qualifications for the contractors installing these systems in the rest of the world, nor, well, I shouldn't say, well, yeah, nor special inspections typically are not a part of the requirements in other parts of the world, requirements of the code. So in terms of gypsum board, I don't want to spend a lot of time here, but in general terms, we have 3 grades of gypsum board: a regular grade material, which is used in non-fire resistance rated construction, typically residential construction, for example. Then we have type X, which is kind of the baseline fire resistive rated gypsum board. Then we have the type C, which is a little more robust panels. I call them a type X board on steroids. Performs a little bit better, uses some additives in the core, which control shrinkage and give it a more structural integrity. And once again, same test standards are used for the gypsum board based products as for the rest of the products. There are methods of preparing panels, gypsum panels. We'll talk about those in a minute. But I talked about the various codes earlier. NFPA 1 is the fire code published by NFPA, and it has some maintenance provisions relating to gypsum panels. It says, where required, fire rated gypsum wallboard that or ceilings that's damaged to the extent that through openings exist shall be replaced or returned to the required level of fire resistance using listed repair systems or using materials and methods equivalent to the original construction. And so there, we'll talk about GA 225 in a minute, is a repair procedure from the Gypsum Association, trade association for those gypsum manufacturers. But it's not as simple as just covering the hole with another piece of gypsum board and screwing or adhering in a place with sealants. Now, it's a little more involved than that. So here's the requirements put forward by the Gypsum Association for repairing a hole. So we see on the right-hand side that we have a hole in the gypsum board. So we cut that around that hole to make a uniform size opening, uniform shape opening, and then we insert framing material through that opening and frame around the opening. You see the screws that attach that framing material around the opening, and then we put another piece of gypsum board cut as close as possible to the size of the opening itself, screw it to that framing located behind it, and then we mud and tape it, finish it, and that creates then a repair process that restores the rating of that gypsum panel, gypsum wall to the original requirements. So moving on, let's look at fire dampers. Fire dampers are evaluated by a wide range of standards. Fire dampers really come in, I'll say 5 types: fire dampers, smoke dampers, or what's referred to as combination dampers, which meet the requirements of both a fire damper and a smoke damper. And then a ceiling radiation damper, where we're penetrating the lower membrane of a ceiling. And then kind of a unique subset of a ceiling radiation damper is what's referred to as a corridor damper. I won't get too involved in that, but so we have 3 standards here in the US. Likewise in Canada, there's standards to cover that. ULC S112 for fire dampers, 112.1 for smoke dampers. ISO has a standard for fire dampers. There's an EN standard, European nation standard for fire dampers, both for fire passage, what they refer to as integrity, or for smoke leakage. There are some pretty specific requirements for installation of fire dampers published through NFPA 80. NFPA 80 is an installation standard that covers both opening protectives, fire doors in other words, and also dampers. So there are some qualified or qualifications and its requirements for the contractors doing that installation, likewise for inspection of those items once they're installed. Here's, I guess, a slide that contrasts the proper and improper way of installing a damper. On the left-hand side, you'll see a very significant annular space around that damper. Well, that annular space has to be protected in some way, shape, or form. So typically in the damper industry, they use steel angles, sheet metal angles around the perimeter of the damper to cover that opening. The opening itself is a little larger than the damper to allow for expansion. The dampers are sheet metal, they get hot, they expand. So you need to accommodate that expansion by creating an opening slightly larger than the damper itself, and then covering that opening with angles that are attached to one element, not both, so that the damper can expand and contract during a fire condition. So if you have these large angular spaces, you've just created a problem for yourself. You've got to somehow fill in that angular space, and typically the listings don't cover how to do that. So you've really created a difficult situation for yourself if that opening is left large, as shown here on the left-hand side. So then we have fire-rated glazing, again used to protect breaches or openings in fire-rated assemblies. In this case, we've got some doors and some windows on either side of that door need to be protected. We typically protect items like that using fire protection rated glazing. Again, fire protection rated glazing is that glazing that gets hot but prevents passage of fire and also meets the hose stream test standards. So there's some standards for glazing when used indoors that they're evaluated as part of the door assembly to UL 10B or 10C or NFPA 252. If they're used as fire window assemblies, they're evaluated to UL 9 or NFPA 257. And likewise, the National Building Code of Canada references testing of glazing to NFPA 80, which describes those same tests shown above. ULC does have a standard for fire protection rated glazing, ULC S106. Likewise, there's an ISO standard that covers flame passage through that glazing material. Likewise, an EN standard that covers the heat transmission, not heat transmission, rather the fire performance, fire protection rating of that glazing material. So here's a photo taken at UL, and this is one of those few cases where you can actually see into the furnace during a fire exposure test. So it's a very unique test. When I was with UL, whenever one of these were running, we'd have a lot of staff members stop by momentarily just to take a quick look, because again, it's one of the few cases you can see into the furnace. So here we've got a fire door and fire windows being tested simultaneously. So for a fire protection rating, the glazing needs to prevent passage of flame. It needs to meet the hose stream test conducted after the full duration fire exposure. But the key for fire protection rating is it does not limit the amount of radiant heat going through the assembly. So it is not a wall assembly, doesn't have those temperature limitations. So if you're this little individual on the opposite side of that glazing, you are going to feel a very significant amount of heat or radiant heat from that glazing material. So likewise, with doors, there's some quasi-contractor qualifications in NFPA 80, likewise installation requirements and maintenance requirements. So here's a photo of some fire doors under test. These are being conducted in accordance with UL 10C. As we can see, these doors did not do well. They we have sustained flaming on the unexposed side, which would not be acceptable performance. And these tests were done in the early days of UL 10C. 10C is what's referred to as a positive pressure fire test. So the pressure in the furnace is higher than the pressure in the lab, so it tends to drive the flames around the voids around the perimeter of the door, ignites the edge of the door if it's a wood-based door, and creates a situation like this. So this was taken in an era where the industry was learning what does it take to pass a 10C fire test. So all door assemblies are subjected to a hose stream test. I shouldn't say all. The standard requires all doors to be tested by hose stream, but the code does have a provision for door ratings 20 minutes without hose stream for certain applications, corridors, for example, with a 20-minute rating. But other than that, doors are required to meet a hose stream. Again, the concept is there be no openings through the door assembly. In this case, the language in the code is there be no, you cannot see an opening through the assembly as viewed from the unexposed side after the test. Slightly different language than ASTM E119 uses. But this slide describes the code requirements for door assemblies, side hinged or pivoted swinging doors, in other words, man doors that we see, UL 10C or NFPA 252, tin clad doors. These are prescriptive requirements on how you build these doors to achieve certain ratings, not necessarily a fire test. 10B is for all other types of doors, rolling steel doors, so on and so forth. It's referred to as a neutral pressure test, whereas 10C is a positive pressure test. And then there's an ISO standard and a BS standard that likewise describes the fire exposure testing of door assemblies, very similar to what we use in the US, other than, again, no hose stream test. And of course, we have the fire stop systems. I'll skip through this pretty quickly since most of you are probably familiar with the fire stop systems. So we establish the individual published fire stop systems through testing to certain standards. The standards define various ratings, F, T, L, W, and M rating. And in Canada, the hose stream test is broken out as a separate test from the fire test. I shouldn't say quite that way. It's all done as part of the fire exposure testing process, but the rating is broke out. So systems that have an F and a T or an FT rating are not required to meet a hose stream test. If a system does meet the hose stream, it's also given a designation of an H rating as part of the published information. And then we have perimeter fire containment. Well, how do we address that void between the exterior curtain wall and the floor slab? We protect it with some material or system that prevents passage of flame through that interior safing slot. Systems are tested to ASTM E2307 here in North America. Canada has a similar requirement, or an EN 13501-2 in the European community. So the codes in the US in particular define various types of smoke rated barriers. An ICC land, smoke barrier, and a smoke partition. A barrier is a more robust assembly that also has a fire resistance rating. A smoke partition is something simply that limits the transfer of smoke through that assembly. Whereas if you have a smoke barrier, you need to, if you have an opening, penetration, breach in that assembly, you need to actually develop tested constructions, material methods that prevent or restrict the passage of smoke through that breach in the assembly. So in the case of the fire stop systems or joint systems, we refer to that as an L rating. For doors, they refer to as a leakage rated door. For dampers, it's referred to as a smoke damper. NFPA has similar requirements for restricting the passage of smoke. In chapter 8, we have quantified fire stop L ratings. In the healthcare chapters, there is no quantified ratings, but there is a generic description for preventing migration of smoke through those assemblies. And once again, the continuity provisions also address the smoke leakage. The UL standard defines a W rating also, water leakage rating, basically the rating that verifies the assembly will first prevent passage of water through the system, and secondly, and more important in my mind, it needs to pass the fire exposure hose stream test after exposure of the water. So if the system gets wet at some point during its life, if you've got a W rating system, you can be confident that the system will continue to provide its fire function despite the fact it got wet. And if it does not have a W rating, the question always exists, will that fire stop system provide its fire performance if needed after that exposure to water? And very likely the answer is no. So an important rating that probably hasn't received its due justice over time. Moving on then, we have an M rating, a movement rating, a relatively new rating for the fire stop industry. And the idea of an M rating is we're movement cycling the penetrant relative to the barrier that it's penetrating. And this is a concept that Bill McHugh actually brought up to UL, I'm going to say around the year 2001 or 2, is that maybe we should be looking at relative movement. Pipes move. We have steam pipes. They expand and contract. We have water hammer. In certain parts of the country, in the US, we have earthquakes, all of which creates movement. Is that going to impact the fire performance of the fire stop? Maybe, maybe not, but let's prove it by test. So that's what the M rating does. Preconditions moves the penetrant relative to the wall, and then it's subjected to the fire exposure test after that movement process. So at this point, I'm going to turn the slides over to Bill. And Bill's got a block of slides here, so maybe it's better he take control of the slides.
Yeah, good stuff there, Rich. Just to continue on with the ratings for penetration, joint, and perimeter fire containment, you mentioned several different accessory standards, I'll say, to the UL 1479, ASTM E814, the W rating, and also 2079. That W rating, pretty cool. And I think you're right. I don't think it's been given its due really enough. It is something that's important. We know that while buildings are under construction, windows are not installed, water, rain, storms come flying in. When people are cleaning floors during construction, they're throwing all kinds of water on it. And then after occupancy, water winds up getting places. A sprinkler system bursts, a toilet bursts, and a whole floor winds up flooded out where all the penetration fire stops are. How's that going to resist that exposure and perform in a fire? That's why it's important, like you had mentioned, Rich, that the fire tests take place after the water exposure. And then the same thing in that movement standard. I know you were personally involved with the W probably, and yes, also the L, yeah. Mm-hmm. The movement standard, Luke Woods was involved at that time, and he was the one that put the negative in to make sure it had the exposure to fire after the movement took place. These other things that you see on your screen in front of you are not part of the fire test standards. W is only water. It's not, pile some hydraulic fluid on it or cleaning chemicals or anything like that on top of the fire stop. That information you have to get from the manufacturer as a specifier to make sure that you're making the physical properties of the products used to provide fire resistance, that they can resist what's expected to happen during fire exposure. And Rich, I'm going to ask you a question a little bit, so you might want to turn your camera back on. Biological agents, what about germ protection as well? Linking the B and the G, if you will. Radiation, what about hospital x-ray rooms? Is there enough radiation that we need radiation resistance above the ceiling? What about explosions? The Ad Hoc Committee on Terrorism Resistant Buildings for the ICC was the proponent to add explosion resistance of certain type to critical shafts in super high-rise buildings 420 feet above lowest fire department access. There's a soft body impact standard at ASTM that's used for that. It's specified in Chapter 4 of the International Building Code as well. So how do you regulate for these? Kind of tough, but for the specifier, you have to make sure to cover these things in the scope of your specification to make sure that the building's protected the way it's supposed to be protected. So before we move on, Rich, there was a question from another specifier friend You went through all the different types of dampers, doors, glazing, all that kind of thing. This person asked, are there still tin-clad doors around? Up, you're off. Your sound's off.
Thank you. I will say, as long as that word around is part of the question, yes, they are still around. Are they being installed? Very, very, very infrequently.
Still manufactured?
I believe they are. I believe there are some UL listings still for tin-clad doors. And in reality, UL's original Northbrook fire testing chamber facility, I should say, was built quite a while ago. And because UL bought it in '56, I believe it was, and it had been an existing building for a number of years. So anyway, point is, there were some tin-clad doors in UL's fire protection facility. So they're still around. Whether they're truly being installed, I guess I don't know.
Good question. Yeah. So I guess to give a hint to the friend that asked the question, take a look at UL Product IQ and hit the search and see what you come up with tin-clad. Do you know what the classification looks like? Does it have a hyphen in it, tin-clad, Rich?
It would have a hyphen. So when you're on the Product IQ online directory, as a keyword, type in tin-clad, or even on the home page, just on that create a search now box, type in tin-clad.
So go to the ul.com/PIQ, ul.com/PIQ, and off you go. If you can't find it there, check out approvalguide.com. I know that FM Approvals did fire doors over many years. Intertech has a long list of tested assemblies too through the Intertech directory of building products. So FM's guide would be approvalguide.com. You got to sign in and leave your name, address, all that kind of stuff. Intertech's directory of building products, you'd go to intertech.com and off you go. So good question. Appreciate you asking that, our friend that I met 1980 something, and appreciate you being on the call as well. And to answer your question about the M rating, I think you and I talked about it, Rich, in 1994 for the first time.
Yes.
It takes time for standards to evolve, as you can see.
It does.
Rich, if you want to jump in and comment as I rattle through the engineering judgments, and engineering judgments get done on lots of different things, not just fire stopping, but fireproofing. You see it, and it's really important to know the protocol. And I think the FCIA's protocol that's in the Fire Stop Manual of Practice really applies to other fire resistance industries too. If you can find a listing, use a listing first. If you find that the listing that you have in front of you as the installer in the field doesn't fit, then you find another system from the same manufacturer. If you can't find one from the same manufacturer that's been submitted already and approved, let's find one from a different manufacturer that's tested and listed in the directories, one of them. And if no system exists, no listing exists in either case, then we start thinking about engineering judgment, following a certain protocol. I don't know if I have that protocol. No, I don't. Let's talk a little bit about engineering judgments and who should be doing those engineering judgments. In FCIA's opinion, it's an and. The manufacturer and. The testing laboratory, I think, is pretty equal to the manufacturer. The only thing they don't know as a testing laboratory is what about the chemistry of those products. So that's why I keep throwing an and Rich, you can debate me a little bit if you want, but the and, in my opinion, the chemistry is known by the manufacturer. Maybe the fire test lab did a test 5 years ago on the product, and formulations changed 3 times. We don't know. How will that affect an engineering judgment? The manufacturer knows that. Well, and frankly, the fire test laboratory should too.
Right.
But maybe the and isn't there for the test laboratory. But when there's an engineer involved, it's always good to have the and. For that engineering judgment. Go ahead, Rich. Hop in.
Yeah, I absolutely agree. The manufacturer's involvement is important. They're the ones who have the expertise on the product. Oftentimes, a code official may bring up the concept of having the testing laboratory write that engineering judgment from the perspective of that code officials. Some code officials view the manufacturer as the fox guarding the hen house concept, and they don't want the judgment coming strictly from the manufacturer. They want a more neutral party, the laboratory, to do that judgment. And the good thing about either the manufacturer or the laboratory doing the judgment is they both have the test reports that describe how the closest available system did originally perform. Was it a nice solid pass, or was it real marginal? And that's part of the process of developing the judgments that the manufacturers use and the UL uses, and everyone should be using. So yes, I do see it as, in most cases, the UL, when a test lab is writing the judgment anyway, they're doing it at the request of the manufacturer. So the conversation and communication is already there.
Absolutely. And the same protocol, in our opinion, stays, whether it's a fire damper, fire door, fire glazing, fireproofing, SFRM, IFRM, and caution has to be taken. You can't just say, well, it kind of might work in that situation without any testing to back it up. It's awfully darn close to what is already been proposed, or to what's in the field itself. Second thing is UL developed a technical evaluation developer program, call it an engineering judgment developer program, frankly, to build more credibility for these engineering judgments. That program is similar to the FireStop contractor program in the way it works. It's not the same. It's different, and its scope is different. Its scope is for developing engineering judgments, not for the quality management system of the contractor. So don't confuse those two things when this thing starts taking off. Make sure you stay on focus with what each one is for. I'll tell you that the FM approvals group decided that engineering judgment wasn't the right term. You see this EFRRA up on the upper right-hand side of the screen, equivalent fire resistance rated assembly. When Jeff Gould was developing the program at FM with the accreditation committee of FCIA, he decided that these are self-certifications, if you will, by the manufacturer, and they ought to declare that it's equivalent. Whoa, that's pretty deep and dark stuff if you think about it. Not dark, I mean, it's deep, and it's protective, if you ask me. It protects the building owner and the occupants that are in the building, because it means someone's going to have to take some time and think about it twice, because they're declaring equivalence to a fire resistance rated assembly. Pretty amazing stuff. We've heard in the field, oh, nobody uses that term. Oh, it's why should we even have it? Well, FM thought it was important to have 25 years ago, and to me, it's still a timely tool there. The International Firestop Council has done a good job of outlining guidelines for engineering judgments, and the engineering judgment criteria that's in the International Firestop Council protocol says that the others, the contractor, the authority having jurisdiction, accepts the Firestop engineering judgment. That FM thing says that the manufacturer declares it to be equivalent, and it changes the position of the person that's using it and then judging it, if you will. Those judgments have to be developed based on existing testing, due diligence, information from the field that's appropriate, used for a single job site, not for multiples, because what if that is proven through testing not to work? They have to cease and desist using it, and the only people that know that are the manufacturers that have developed it and used that engineering judgment. It's got to have the job name on it, the contractor name on it, the project name, as I mentioned. So there's a lot of communication that goes on, and these are not taken lightly. They do cost time on the manufacturer's point, and that's all built into the cost of the product, if you will. The engineer is going to charge money for it. If UL does an EJ, I'm sure they charge money for it. So just know that this is not something to take lightly in the field. Any further comments there, Rich?
No, I think you've covered it well.
Appreciate that. Okay, so we've been talking for an hour and 20 minutes. We haven't really showed much in the way of installation stuff. So what happens when we get to the field? The IIM, the installation. the FCIA was a code proponent to put in the International Building Code, Chapter 7, to install these products in accordance with the listing and the manufacturer's instructions. Penetrations, joints, perimeter fire containment, and the fireproofing too. We haven't done much in the fire doors, nor have we done it in the gypsum wall gypsum panel area or concrete block or any of that stuff. But yeah, maybe that's future code proposals for others to bring forward as the 2020-30 code gets developed, because we're already done with submitting things for the 2027 version of the International Building Code. So listings first is what that contractor personnel should be doing, and understanding what the size of the opening is or the breach, understanding the size of the penetrating item, and then applying the sealant or FireStop products with the appropriate safety equipment on. Take a look, glasses, hard hat, gloves, all are on the safety data sheets for people to use. So these are the things we look for. We're going to look at how fireproofing might mix with fire stopping at the head of wall. Important to know these two things, you know. Look for the P700 series, P900 series designs for the deck, and it might have spray applied fireproofing on it. And then what do we do with the FireStop system? Some FireStop systems are not allowed to have the FireStop products touch fireproofing. What do we do then? Do we take off the fireproofing? No, we'd be better off finding a listing that has fireproofing integrated with the FireStop system in the listing itself. And as you can see there, this HWD-0300 erector seal system shows a beam, holding up the horizontal assembly, and that's where a wall might be positioned underneath it, so that that wall and the beam become a fire resistance rated assembly. That beam fireproofing is going to have to be thicker than it normally is in order to provide protection as a wall. You heard Rich talk about the temperature limitations on the non-fire sided assembly. Was that 250 plus the ambient, Rich, right?
Yes, that's correct. Took me a minute to get the microphone back on.
It's all right. We always get confusion about that particular number. So that beam, although it's functioning to protect the steel, is also acting as part of the wall, as you can see in the right-hand side picture. So the beam has to not transmit heat to the non-fire sided assembly. You also saw that in the fire rated glazing type applications that Rich showed earlier, fire protective versus fire resistive glazing. Moving on, the head of wall sometimes has intumescent strips alone used at the head of wall without much sealant as well. Maybe it's put on to the top of the track. There's a certain limitation to the size of the space, to the walls, to the steel track that's used. All of this is specified in the listing before any of the installation can be done. That listing has to be looked at in great detail, regardless of the manufacturer of the FireStop product that's used. In this type of an application, maybe there's a spray that's been used, maybe there's a sealant that's used, maybe there's tapes that are used. All of this has to work together in order to provide a fire resistance rated assembly. This HWD-0259 is a little better description of a gypsum wallboard assembly that's meeting the bottom of a beam that's supporting a fire resistance rated assembly above it. Again, that thickness of fireproofing at the web, kind of where the 1C and 1D are pointing at that web of the steel, that's where extra thickness of fireproofing needs to go. So, as a specifier, maybe you point out that somewhere in the drawings, that the wall and the beam are one, and that the beam is functioning as a wall in addition to the wall itself. That way, the fireproofing industry understands, and the general contractor understands that there's more fireproofing required there, and it doesn't get missed. That can be a big miss when it comes to estimating the thicknesses and the amount of thickness that's there as well. So, here's all the temperature rise and the non-fire side of the assembly. Rich has clarified this nicely so that, right here where it says increased fireproofing thickness, it's a key thing to kind of keep in mind, because there can be miles of walls, there can be miles of fireproofing that's needed to be done too. Fire-rated expansion joints, there's all kinds of them, whether it's from Balco, Inpro, MM. These photos show the various types of materials. Upper right would be the foam type, expanding foam sealant with silicone on top. Upper left is showing maybe a ceramic fiber material, insulation with foil on it that's installed in a certain size joint with a limitation of movement capability. They'll have a certain F rating, a certain T rating, temperature exposure rating. Bottom left is showing the endothermic mats that are used for the same thing. There's lots of different ways to get fire resistance done. What the specifier has to do is figure out, is the upper right-hand one appropriate? Is the middle metal expansion joint required, depending on the traffic, if any? And then there's a cost associated, obviously, with each one of those types of assemblies. So here's what the FD 4001 would look like. You know, the specifier would say, give me a fire resistance rated assembly with a mechanical joint top of some kind. Maybe it's aluminum, maybe it's steel, whatever it is, aluminum, bronze, steel, from multiple manufacturers, but it's got to be a 2-hour rated, and it's got to be able to extend and compress 50%. As a specifier, that gives you the generic language. The contractor can then go to specified or to construction specialties, MM Systems, Balco, and say, all right, I need this kind of a joint. And that's where the competition takes place that the specifier is looking for to get the best price for the building owner and manager. So we've talked about design, we've talked about a little bit about install, but let's talk a little bit more about the FM and UL contractor programs. This slide that you see in front of you is something I've been using since 1990. Yes, I should have copyrighted, but you know, what the heck. That's not all we're here for. We're here for making sure that fire and life safety systems are installed appropriately, and that we save lives when we do these things right and educate. What's the first thing that a contractor has to do to figure out which systems am I going to select? What does the inspection agency have to do to analyze those? To us, the contractor is responsible for selecting those systems. From an architect perspective, it's next to impossible to specify the exact system for each project. It creates a closed spec, which the architect and specifier may or may not want to do. The building owner may want to have competition amongst manufacturers to come up with the best product price, and there's competition to get, you know, with contractors to come up with the best installed price. There's competition amongst special inspection agencies to come up with the best inspection price as well. So, you know, looking at the long view, these are the things that are required for all of the entities to select, analyze, and believe it or not, maintain protection. When looking at the wall or floor construction, got to figure out what the fire resistance rating is. What's the type of wall? Gypsum panels, concrete block, clay tile block, as Richard pointed out, the archaic assemblies. What is all of this stuff? How thick is that floor or wall? What are the penetrating items going through it, or what's the joint size or breach size and the gap size? Is the penetrating item, what type is it? Plastic, metal, aluminum, glass? Is there pipe covering on that assembly or duct work? Is there duct insulation on it, and what type is it? All of these things are going to burn differently. They're all fire tested, not differently, same test standard, but they're tested and have different results. And then what are the materials used to provide the protection of that breach so that we maintain continuity of fire resistance through the breach? And that's a key point. It's the scope of fire stopping. It's not sealing the pipe, it's not sealing the wall. It's maintaining the fire resistance rating of the wall or floor assembly through the breach made to insert a penetrating item. And that particular scope gets lost in our industry. We hope it changes, you know. We hear many of us in the industry, you know, me included along the way, say, hey, let's go seal that opening. Well, we shouldn't be saying that. We should be saying we're going to protect the breach with a fire stop system that provides a 2-hour F rating, 0-hour temperature rating, an air leakage rating of less than 1, and a W rating of class 1. That's really what we should be saying, because that gives us the scope of what's happening with this particular assembly. Then it's installed in accordance with the manufacturer's instructions and the listing. And that's a key thing. Other key thing is that we did a code proposal for the 2027 version of the building code, got approved at 2 different hearings, that says the listings need to be at the project site. Huge. That's a big change. And we're going to need our specifier friends to start sticking that into the specification to be sure that they reflect what's coming in the code development process. So this young person here on the bottom of the slide doing the right thing. Safety data sheets, product data sheets, listings, and then the life safety drawings that give that person the map as to where the fire stops get installed. I'll invite you to spend time with any of our manufacturer friends to talk about their products. And you can also spend time on the FCIA's Firestop Education Program Level 2. That's where you'll find the advantages, disadvantages, limitations of use, and how they are used in a system for each one of the products in the Firestop industry from a very generic perspective. Very industry specific, not not manufacturer specific. Who installs this fire stopping? Well, it's still kind of a mess. I'm guessing probably between 30 and 60% of the fire stopping in the world gets installed by a specialist fire stop contractor. The rest of the time, and that trend is moving, it's going up and up and up. There are more and more jurisdictions where fire stopping is being done by the specialist contractor. It's being driven by general contractors getting sick and tired with somebody just flinging fire stop goop there, and an inspection agency catching that the goop isn't the system. That's happening a lot more. So in other words, the strategy we laid out in 1999, how about we have qualified contractors, good quality contractors? How about we have inspection? Those 2 things working together are starting to really show results in our opinion. So he or she who pokes the hole fills it is one way. It's getting less and less. Sometimes the he or she who pokes the hole fills it, and then maybe a specialist contractor working for some of those subcontractors, or working directly for the general contractor and the others doing self-performed work. And then again, this single source fire stop contractor who's competing against many other fire stop contractors, because there's hundreds of UL qualified FM approved contractors throughout the world. Those companies are installing more and more from what we can see in the industry. Those 2 standards, one standard plus 1 program, if you will, the FM 4991 program is a standard for the approval of the fire stop contractor. UL qualified fire stop contractor program, very similar. Both of them are quality management system programs, but it's called a program operated under an ISO type standard, 17002 or 5. I don't remember which one, but they're both credible programs run by nationally recognized testing laboratories. And they're management system programs that produce documentation for the fire stop contractor to give to the building owner and manager. How do you get approved by or qualified? Pass an exam from either organization, depending on which one you choose to go with, at an 80% minimum. Have a management system that's written, that is up to date, that's followed and implemented at the company, and then get audited by these organizations for an initial audit and then annually. How much this stuff costs? Anywhere from $9,000 to $15,000 for the original, and then $4,500 a year, $3,500, $4,500 for the ongoing maintaining program. I can tell you that 4 football games and 4 dinners at Ruth's Chris Steakhouse probably did that initial, and then we've well covered the ongoing one as well. So looking at the programs, take a look at where you can find them: FCIA.org, UL.com, Product IQ, and then of course the approval guide from the FM approved contractor. The management system, I'll just spend a few minutes. Contractors have a purchasing program. They've got a written purchase program, a written procedure for how they communicate listings to the field. They keep the records of the fire stop systems for a period of 7 years, and then independently these guys and ladies get audited by UL and FM. Let's talk for a bit about inspection. There are 2 standards, ASTM E2174 and 2393. Those 2 standards at ASTM were the result of a question at an FCIA meeting. How do we inspect fire stops? and how do we put it in the code? Got to have a standard, and we put it in the building code. Thanks to Bill Koffel, FCIA's code consultant, who helped us get it over the top at International Code Council, and also at NFPA 1 and NFPA 101, where you'll see references to the standard required in NFPA 1, referenced in NFPA 101. Types of buildings: high-rise, residential, greater than 250 occupants, and then also critical buildings in category 3 and 4, table 1604.5. So that's like schools greater than 250, hospitals, police stations, fire stations, air traffic control towers, water treatment facilities, water stations, all that kind of stuff is in table 3 and 4, table 1604.5. What about other items that get inspected? So fire stopping is inspected, but what about others? Fire dampers, it's inspected at commissioning after 1 year, and then every 4 to 6 years. 4 years for every occupancy other than healthcare, hospitals, and then every 6 years in hospitals. So I got a little bit of the I and the I and M. The M is after 1 year, that's maintaining protection, same with the 4 or 6 years. And then fire doors and glazing, NFPA 80 has something at commissioning. The International Fire Code covers the annual. You'll hear about that from Rich later. Fire walls and floors, International Fire Code's about it. There's not much when it comes to third-party inspection of those. Structural fireproofing, Chapter 17 has it all the time for spray fire-resistant materials, intumescent fire-resistant materials, and then boards and wraps. There's a standard being developed, but in 1702.1, those materials should be inspected, independently inspected as well. Special inspectors ought to be competent in the type of inspection they're doing. How do you prove competency? Pass an industry exam. FCIA, the International Firestop Council, the UL, and FM Firestop exams. I think those two are probably the best when it comes to fire stopping, the UL and FM exams, because they're objective third party. Certainly the FCIA and the International Firestop Council are also a third party, but it gives you a little extra level with those other exams. There's also other ways to qualify as a special inspector, including the International Code Council Certificate of Learning Achievement, etc. The inspectors should not be competitors of the manufacturer, the supplier, the contractor either. When it comes to maintaining protection, NFPA 101 is pretty crystal clear. Look at Chapter 4, and this hasn't changed into the 2024 version of NFPA 101. And look what it does. It's got fire resistive mentioned twice. It's on line 2 and line 5, where it talks about fire resistive construction, continuously maintained. So that doesn't mean, let's say every year let's go do a repair. Nope. When you find out it's broken, it should be fixed and maintain protection for the life cycle of the building all the time. Continuously maintained in accordance with NFPA requirements. Those are covered in lots of different areas throughout NFPA 1, NFPA 101 in the NFPA world. The NFPA 1 is pretty crystal clear about maintaining protection. And this language, fire resistant construction, it's covering everything. Fire resistant requirements based on type of construction. That's going to be the structural fire resistance assemblies. Fire barriers, that's walls. It's also horizontal assemblies. And look at this, and roof coverings. Holy cow. So when a fire resistance rated assembly when a roof is a fire resistance rated assembly, okay, think occupiable roofs now. Think hospitals where they're doing future floors. Got to make sure that the roof covering maintains its protection. And this language you see here shall be maintained, probably repaired, restored, or replacement damaged, altered, breached, or penetrated, removed, or improperly installed. I love that improperly installed. The trial lawyers will have a lot of fun in if there's loss of life or loss of property, pointing to that building owner responsibility. So Rich, I'll let you take a couple of minutes to cover these next 2 slides. Just tell me when to move from one to the next.
Okay, will do. So now we're talking about the requirements of the International Fire Code. And International Fire Code was revised with the 2018 edition to very clearly identify what assemblies need to be maintained. And previously there was some language, it was sort of intermixed between the basic barriers and the penetrants and joints, doors, so on. So we basically split it up and created individual sections dealing with each of these items. So starting with the scope, the provisions of this chapter shall cover the inspection and maintenance of materials, systems, or assemblies used for structural fire resistance rated separations, and constructions installed to resist passage of smoke. So it covers all three of those. Why don't you go on to the next slide then? Can you move on to the next one, Bill?
I did.
Oh, I'm sorry. There we go. I'm looking at the wrong screen. And then
That's okay.
Very important is owner's responsibility. The IFC uses the philosophy of putting requirements on the owner of the building in a couple of respects. First of all, they need to maintain an inventory of required fire resistance rated construction. How do you inspect it and maintain it if you don't know it exists? So number one, you have to have an inventory, you know what you have. From there, such constructions need to be visually inspected by the owner annually and properly repaired, restored, or replaced where damaged, altered, breached, or penetrated. So that's some pretty powerful language about inspecting it and making sure it gets repaired. Now, does this mean the actual building owner himself does it? Maybe, maybe not. If it's a large corporation, probably they're going to hire third-party organization do those inspections. For example, an FCIA member would be a suitable party who could do that work as long as they're not also fire stopping it.
Yeah, one thing I would mention too, Rich, is, I'm sorry, go ahead, you finish up.
No, I was just going to say the last point here is you need to maintain records of those inspections. They weren't done if you don't document the fact they were done. Very important.
So the U is, as Rich had rightly pointed out, is the building owner and manager. This is where all passive fire protection needs everybody's help that's on this call or on this webinar. Those of you that have clients that have buildings with lots of fire resistance rated assemblies, maybe you're in there for something else, pipe covering, caulking, sealants, waterproofing, tools, whatever. Mention to your building owner or manager friend, the facility director, hey, look, there's a responsibility that's in the fire code that you might not be aware of. And this 701.6 section clearly lays out what you need to do when it comes to passive fire protection. It seems that if you ask the facility director, what do I do with sprinklers? Oh, sure. Every year we take care of them, make sure they work. Fire pumps there, everything's functioning. Alarms and detection. Yep, we test the alarms as well. What about the passive fire protection? You'll get a blank stare usually when you do that. So for our friends on the webinar, spread the word and use this slide to do it.
Yeah,
thanks,
Rich. I
Rich.
guarantee you that many building owners are not aware of this. And I'll also probably venture to guess there's a number of fire inspectors, fire service people that are not aware that this is there and or more importantly, not enforcing it. So this last slide is also pointing out that the International Property Maintenance Code also has requirements for maintenance. That last paragraph, required fire resistance rating of fire resistance rated construction, including so on and so forth, shall be visually inspected annually by the building owners and repaired and so on and so forth. Same language is in the fire code. So ICC is hitting on it from several different directions to make sure this is done.
Cool stuff, Rich. One thing that a question came in from a fire official. Well, we don't have this in Pennsylvania or Illinois or whatever state. Well, go back to whatever the fire code is that's been adopted, and likely it's NFPA 1 or 101. Guess what? You've got similar language sitting here in NFPA 1 and NFPA 101. The building owner manager still has responsibility to maintain protection of fire resistance rated assemblies. Quite clear in NFPA 1, the fire code, chapter 12, and then NFPA 101 has it too. And even if they don't, let's say it's something else. To me, I'd still explain to our building owner friend, hey, guess what? If there's loss of life or loss of property, where do you want to be sitting when there's a jury trial? In row 1 of the audience or on the stand? Because if it's proven that something happened and the proper repairs, restoration, damaged, altered, and breached, penetrated, if it wasn't fixed, and you are responsible for maintaining it, guess what? You're sitting on the witness stand instead of in row 1 or row 2 of that assembly. Same thing with the National Fire Code of Canada. Even though it doesn't come out and scream what the other codes did prescriptively, because this is a performance-based code, it does mean that fire separations and the structural portions that are supporting it need to have their integrity maintained, the integrity of the fire separation maintained. Any damage, doesn't matter what kind of damage, any damage. Maybe it's too much combustibles on top of the wall. Maybe somebody decided to do some artwork or something crazy like that. That's the responsibility of the building owner and manager to maintain. When it comes to fireproofing, same thing in the National Fire Code of Canada, where structural is there, the material that's damaged or removed has to be repaired so the integrity is maintained. Go to the United Arab Emirates. Well, I'll be in 2 weeks hanging out with my friends in Dubai. Same thing, replace it with new ones. This one only talks about fire stop systems, but you know how lawyers are. They'll twist it and say, look, a fire stop system, in order to work, it needs the wall to work. And you didn't maintain the wall, so therefore there's a problem. So guess what? We're in the same boat, whether we're in the United Arab Emirates or in Canada or in the US or in other parts of the world too. A visual inspection, owner or the owner's representative, and then damaged, breached, and penetrated needs to be fixed as well. Go to India. I like this one. The owner, engineer, construction, occupants, and the maintenance agency are deeply involved in the process to make sure that safety is maintained in a building when it comes to asset and facility maintenance. Guess what? The fire stop systems, the fire dampers, fire doors, fire reglazing are all part of that too. Go to Saudi Arabia. It looks just like the NFPA 101 in section 107 maintenance. Maintain in accordance with the code and applicable standards. One way to help building owners get this done at new construction and fire stopping, for instance, is, and maybe this can extend to a passive fire protection inspection, is using this UL Master Audit Certificate of Compliance. What it does is has UL come out and verify that the contractor's management system was followed installing these fire stop systems. And in order to renew it, it has to be done annually. So think about that when specifying as well. So let's covered all of the 4 corners, if you will, of this, and I've got about 7 minutes left. I'm going to go quickly through these next few slides so we can get to some questions and go from there. I do have another question that came in about the IAS AC 291. That's back up in the inspection. The AC 291 that I covered really quickly is the inspection agency qualification. So the International Building Code in Chapter 17 has 2 approvals for the inspection entity. One for the company, so the jurisdiction has to approve the company that has experience, equipment, and employees as a special inspection agency. The second approval by the authority having jurisdiction in Chapter 17 of their National Building Code is to approve the individual inspector that they have experience in the same type of complexity of materials inspected, materials and systems inspected. Those are 2 approvals. The first one gets missed all the time in specifications and also by the jurisdictions. They seem to focus heavily on the qualifications of the inspector and forget about the inspection agency company that's supervising the inspector and telling them what to do. That's where the IAS AC 291 or a program like it comes in, where the management system of the inspection agency has been audited by a third party, like an International Accreditation Services or others that do that kind of work. So that's where that comment came in to answer your question. So moving on quickly on existing buildings, these requirements have been there for decades. We know the building owner and manager does the sprinklers and alarms, but what about the fire separations, the fire barriers? Not much there. This slide, if you want to take a screenshot on it, is kind of the process that the building owners or managers should be using to protect their passive fire resistance. Create the inventory, life safety drawings, manufacturer's instructions, listed systems I add to it, safety data sheets. Implement fire resistance management, whether it's for everything, not just the fire stopping, for doors, the dampers. Doors need to open, close, and latch under NFPA 80 and be inspected annually. Fire dampers, you saw every 4 years or 6 years. The fire rated glazing, got to make sure it's still in the frame, still attached, has a bug on it that tells you, the bug meaning a little mark on it that tells you the fire rating, whether it's an opening, has it passed a hose stream test, is it used as a side light, all that kind of stuff, and for how long is fire resistance rating. All that stuff's got to be inspected annually by somebody. That's what the fire code says. We can go into another day, another webinar to give you the very specifics of each one of these so that you can understand more about the annual inspection, the responsibility of the building owner, and we think the fire marshal and insurance company as well. So again, I mentioned the different types of things that are in that inventory. I will tell you that the specifier can set the stage for this by mentioning in Division 1, 07017839. How do I know this is a section? Dennis Hall, who put together master format for the 246-digit program in the 2003-4 timeframe, was the master format test team chair at the time for CSI and CSC to get this done. Know that you can do this in each one of the disciplines: fireproofing, fire stopping, fire rated doors, dampers, glazing. Put something in Division 1 that references back to each of these individual sections. It says gather documentation and pass it to the general contractor over the building owner and manager as their passive fire protection inventory document. That's what you want to do. Use 017839 for that, and don't forget to refer back up to the other divisions for all the things that are needed there as well. There are contractors that specified in this that specialize in this maintaining protection, and they are located worldwide that do all passive fire protection, not just maintaining the fire stopping, but rebuilding the walls, checking the dampers, do they open, close, and latch, whether it's remotely or checking them at the damper location, making sure it still has the angles around the perimeter of it, making sure the doors open, close, and latch, that the gap between the vertical and underneath the door is appropriate. All the things that need to be done in an inspection of some kind. So again, use that master format Division 1 for doing your thing. When it comes to fire stop specs, we say specify it in one place, 078400. That's why that sits there. Most of the large firms do that now. They don't use all the other places for fire stopping because, each of these might get used at different times in different projects and requirements might change. No fun when you get specs that conflict with each other. Keep it all in one place so that it's one spot, one section all in one. You can edit it, take out the joints if you don't have any joints, take out the perimeter fire containment if you don't have that, and just leave the text for each of these in one place. What does the scope look like? Effective barrier, and use the standards to limit FLW, fire temperature, water hose stream, all that kind of stuff. Fireproofing, same thing. Use the general spec for that as well. Moving on, we'll move forward and use this for another specification day, another time. Just know that in your specification, ask to protect the breaches in fire resistance rating assemblies with a fire stop or fire damper, fire door, passive fire protection for structural purposes, the horizontal assembly, and the wall assembly, and install that in accordance with the listing in the manufacturer's instructions to come up with that system to get things done. When it comes to repairs, repair it in accordance with the listing and the manufacturer's instructions, the manufacturer's repair instructions. Starting to see manufacturers come up with more documentation for repairs and their recommended methods for that as the industries mature more and more. I had put this up earlier, so I'll skip over it and get to the most important part, which is the questions. Look at that, finished right on top of the hour, Rich. You're amazing. How did we get that done?
Yep, you are. You caught up after I got behind.
That's okay. All right, so looking at the chat box, I don't see anything. I was trying to keep up the questions as we went on the question box, and I'm not seeing anything there other than, what about handouts? This presentation will be available, a recording in the members only section of FCIA.org. And if you want to see the slides, they'll be in the webinar section of FCIA.org as well, so you can go look at those. So we'll stop at this point and say, okay, are there any questions? And while I look for questions, Rich, any closing comments?
Not particularly, no. I suppose there's a lot of good information, covered all four sides of the DIIM concept. Perhaps we could spend more time on specs, as Bill mentioned. Maybe that's another future webinar, but no, just be aware that there's a lot that goes into fire resistance and properly speccing it out, installing it, inspecting it, maintaining it. It's a life cycle process.
Yeah, really, really well said, Rich. How many times have any of the people on the call that are in the fire stop industry, you and I, how many times have we heard, yeah, we're going to fire caulk that. It'll be just fine. Like, nah, I don't think so. The language we teach has to continue to evolve to, okay, we're going to protect the breach with a listed system installed in accordance with the manufacturer's instructions, period. It's a mouthful, but guess what? That's our world for fire stopping. That's our world for fire doors, fire dampers, fire glazing, and frankly, the wall itself as well.
Absolutely.
So looking down, I don't see any further questions, Rich. I guess we've solved all of the world's fire resistance problems in 2 hours. Very good. So not seeing anything, a big thank you to you, the audience, for taking some time to be with us today. We appreciate it. Thank you, Lindsay, for setting this thing up, and Carol Ann and Lisette for supporting us. Thank you, Rich, for taking the time to do this, and we'll look forward to seeing you in a live program in Doha in about a week and a half, and also in Dubai in about a week and a half as well, or at the next FCIA event and webinar. Thanks, everyone. Have a great week, and we'll look forward to seeing you soon.
Yeah, thank you, everyone.